AI is seemingly everywhere. One thing is for certain, and that is when AI servers are training across a switched network fabric, the traffic patterns are unlike anything generated by humans. The traffic is different, and thus the testing needs to be different. That is our topic today, and we are happy to have an expert with us from Spirent, Mr. Asim Rashid, to unravel some of those mysteries. Asim, welcome. Please introduce yourself and your current role at Spirent.
Hi, Kevin. Happy to join this conversation. I manage the high-speed Ethernet product line at Spirent.
So we're talking today about AI testing, right? As I said, AI is everywhere. Everywhere you look, you see AI. So what are some common misconceptions about AI testing specific to the switching industry? And maybe along with that, what do people overlook when they think about AI testing or underestimate for AI testing in the switch space?
Thank you. That's a very good question. From my point of view, there are two major misconceptions when it comes to testing the AI infrastructure. The first misconception is that um, folks think that they can take the existing test methodologies and transfer them over when they are emulating the AI test infrastructure, and it doesn't work. And the reason being that the AI infrastructure generates traffic patterns that are unique to AI workloads that are not found in traditional network testing.
Right.
So to transfer over traditional network testing onto AI infrastructure, it doesn't work because you need new paradigms of testing that didn't exist before. The second misconception is that the existing way of measuring the performance of networks would carry over to AI networks.
Okay.
But AI networks, because of the unique traffic patterns as well as the unique requirements of those networks, require new metrics. For example, job completion time that didn't exist prior to AI network testing. So those two misconceptions are the ones that hold back the test success
Yeah.
under real world conditions.
All right. And of course, your point is well taken. Um, you say you can't run those old tests. Well, I think one of the problems is you can. You can run them on your switch infrastructure, but the results won't tell you anything, right? You can run an RFC test across your switches and get results, but they won't tell you how AI is going to perform because of the reasons that you just mentioned. And things that we've thought about for literally decades now of just, raw throughput, et cetera, things like that are not going to be indicative of the performance that we're going to get with AI because of the fundamentally different approach with AI. So I agree with everything you're saying. So then, what's needed? What challenges do customers face when they move from, what are we going to call it, legacy switch testing now to AI switch testing to get information that they need that's useful in projecting the AI performance?
Mhm. So there are three different elements of the challenge that's that's seen out in the production networks. First is the massive scale of the AI data center. So the scale is something that's unseen before. So that's number one. Now, the second is what I had previously mentioned, the unique traffic pattern. So the traffic pattern is not just unique, but it's also very complex. So the challenge as far as testing is to for the end user to be able to emulate complex traffic workloads. And next is as the networks are used by the uh, large models during their training, the networks have to be really robust. So that is another element of the testing that needs to be focused on, that how robust your network is, because of the massive scale and very complex traffic workloads.
Okay, a couple of questions there, and then I'm going to ask you if you have some real world examples of this. So,
Mhm.
granted, we hear about massive AI data centers, but just from my own experience, typically when we're benchmarking infrastructure, we're benchmarking in a test environment where we have a limited infrastructure. So, how does
Right.
that play in, or how does that relate? I mean, clearly, we can't shut down a massive data center just to test it. So, how does that all fit in with traditional testing in a lab versus dealing with AI testing?
Yeah, so there are two elements that you touched upon. One is the traditional way of testing, which was to without the test equipment, you use the real elements of your network that you're testing. So you
Okay,
combine, you connect all of the elements in a lab and you blast traffic through them.
right.
Well, it doesn't work for the AI testing. Why? Because of the huge cost involved, not just on the network elements, but also now you have GPUs
Which are
that
massively
are
expensive.
deployed.
Yeah,
Sorry?
the GPUs are very, very expensive.
They are very expensive. We are talking hundreds of millions to billions of dollars, depending on the deployment. So what we say is like it takes a data center without a
Yeah.
specialized test equipment. It would take a data center to test a data
Data
center.
center. Okay.
So that's number one. That's the capex or the high cost element because and then there's that other element that's behind the scenes, like you have to procure, you have to deploy, you have to manage all of that test infrastructure in order to be able to emulate real world conditions.
Right.
And then afterwards, you have to monitor not just the pre-deployment, but after deployment, what is the power consumption? Now, power has become a real problem for real life data centers. Power consumption is a major headache that's actually becoming a bottleneck in the growth of the AI data centers because of the huge scale and the amount of power that they consume. And afterwards, how do you analyze? How do you analyze the massive amounts of data from results, and how do you make sense of those results? So what has happened is that now the burden falls on the end user to go through all these levels and understand all the nuances and then make sense of their testing so that um, it makes sense to them. So that requires that's putting the burden on the end user. And
And
these are the
that's a big
challenges.
burden for sure.
Mhm.
Yeah. Asim, can you please describe Spirent's core offerings, how AI testing fits into your portfolio, industry customer types you serve? And if you have it, it would be great to see a real world example.
Sure. So Spirent was the first to offer a product for AI network infrastructure testing. What we offer is a comprehensive solution to validate data center fabrics as well as the elements that go inside that fabric by generating realistic workloads and repeated testing for accurate validation because you need your testing to be repeatable so that you can test your infrastructure. That offers to our customers is a lower cost and power consumption. Your maintenance costs go down, and um, it does not require AI experience to in order to test your infrastructure, and it builds upon the 2 decades of Spirent experience in Ethernet in offering industry benchmark testing for Ethernet. This time built for AI and networking use cases. To your second question. Uh, we have a customer that was in the midst of building a new AI data center, and they needed to expand the footprint for newer and existing customers. So the challenges that they were facing if building an in-house solution was poor AI workload recreation in the test infrastructure. So this meant also that their solution they needed could not scale up to the higher scale required, the huge scale required by AI networks, because we are essentially emulating a real world AI infrastructure,
Right.
right? So the customer needed um, all of this as they were evaluating different solutions. So to determine which which software and hardware solution to incorporate and deploy in their AI data center. So they needed a test solution to quickly validate the different vendor offerings that they were evaluating and roll out the right solution that met their current needs as well as open to future upgrades. And that's where we came in by offering hyper realistic AI traffic, high port count, and offered a better ROI and a feature roadmap that grew as the industry evolves to meet the AI needs of the future. So I'm going to give you an example of a customer of ours who needed to run scale tests across layered fabric and analyze the test results, which was difficult for them because they were also debugging the fabric and trying to find where the problem in their fabric lied. So they partnered with us to run tests using Spirent solutions that were consistent and emulated real-world traffic patterns,
Mhm.
and that provided afterwards detailed statistics on the performance of their AI fabrics. So this helped them evaluate their fabric architecture using a neutral third-party solution.
Good, good. So then this is core to Spirent. So can you discuss some of your AI offerings and how AI testing fits into your overall portfolio?
Sure. So just a brief background, of what I had mentioned previously. So Spirent is emulating the GPUs, and this is our methodology where instead of purchasing and installing and maintaining the huge network infrastructure of GPUs and servers, Spirent will emulate the GPU traffic that's coming into the network. So that lowers the TCO, total cost of ownership. It Spirent takes on the expertise part, and the test coverage is much wider and more specific to validating AI networks.
Let me ask you a question. The point you brought up about the GPUs is critical, right? So um, the switches need to see realistic GPU traffic. So I take it what you've done is you've modeled that traffic. So you know in a given training scenario what the traffic would look like across the servers and through their various training cycles, and that is what's going across the switches. So from the switches that the network infrastructure that's being tested, it looks like GPUs are communicating across them. Am I correct in that statement?
You are perfectly correct. So when the fabric, because we are exercising the AI Ethernet fabric, from the perspective of the fabric is going to see the traffic patterns that real life GPUs would generate in a real network. So when we are exercising the fabric, the fabric will get traffic as if a large number of GPUs are using the fabric itself.
Okay, and I don't know if this is the right way to ask this question, but when we talk about traditional switches and we talk about statefulness of sessions and buffers and overload, we know that when switches when let's say a backplane or a leaf and spine connection gets overloaded, traffic will be delayed or dropped. Is that something that your test solution can address so that they can find if there's parts of their infrastructure that are not built properly?
Yeah, so the traditional metrics of infrastructure measurements don't go away.
Okay,
They're all there. For example, packet drops,
right.
latency, jitter. Those statistics are there. The traditional way of measuring network performance are always there. What Spirent solution does is adds another layer of insight onto the traditional way of network testing.
Okay, excellent, excellent. So then, obviously AI is continuing to grow in importance.
Mhm.
Seems like almost daily. Would you be able to tell us a little bit about your roadmap of what you see the next challenges being and where you're planning to go in terms of bringing the product line?
So what's next? There are multiple aspects. As the models increase in their parameters, and they will continue to increase in parameters, the need from the test vendors is to make sure that the test solutions are realistic and can scale. And this is what at Spirent we are working along with our partners to make sure that we scale our AI test solutions scale, uh, that our AI test solutions meet the increased realism and scale requirements of our customer uh, testing. Another element is because of the increased scale of the large language models, there is a huge demand on the Ethernet side to move up on the speed.
Okay,
So where things used to work on a 400 gig, now there's already deployments on the 800 gig front. So 800 gig Ethernet support um, is going to be added. In future, on the technology side, the industry is working on 1.6 terabits per second. So the Ethernet specifications are being worked on, but that's coming in the future. And Spirent is planning on supporting our customers when they move to 1.6 terabits per second. And lastly, there's another element of the ecosystem where the Ultra Ethernet Consortium is going to uh, add new features to Ethernet
okay,
where these features are focused on the AI data center needs so that Ethernet is more capable of serving the unique requirements of AI workloads. So those four elements combined, the realism and scale, the new Ethernet speeds, as well as new protocols that are being developed to enhance Ethernet. That's where Spirent is heavily involved in all those four elements, so that we continue to offer our customers a broad and deep AI test solution.
sure. Very, very powerful roadmap. Okay, terrific. Great. All right, thanks for those important insights, and thanks everyone for joining us today.
Thank you.